Thank you, and yeah, a bit of an audacious title, but we'll see how we go. So, brilliant. So I use this slide a lot among various presentations, but the idea here is to articulate, and I'm sure a lot of you have seen this kind of thing before, how a lot of the time we are doing some stats work, we are then taking the outputs from that stats work, maybe some summary stats or whatever it may be, and inputting that as inputs to a model that's built in Excel or VBA. Some plots that are output from that model are then copy and pasted into a Word document, along with often tables from the model, so output tables, and then that's presented in, say, PowerPoint format or equivalent. And so a lot of what we're trying to do and work towards, and we saw this earlier with the presentation from Aline, is how do we start to take some of those components, some of the stages of this, and streamline it and make it more convenient. And so what we want to move towards long term, hopefully, is a system where we're doing some of the stats and modeling work in R that's feeding directly through into outputs in terms of visuals using the ggplot package. And we heard in the last talk about Warden, one of the questions around how can we work together to make sure that different packages are interoperable, so we could have a package to do some visualizations, a package to do certain types of modeling. How do we have a nice pipeline that feeds through? But what I'm going to focus on today is more around the RMarkdown side, more around the reporting side. So if you have a lovely input template that's maybe in Excel that you can share with people, as per Aline's talk, and then you've got a fantastic model that you built using a variety of package options or in base R, but then how do you get that to spit something out that's really useful for stakeholders? And so we've kind of been on a bit of a timeline, or I've been on a bit of a timeline with R-HTA. So we gave talks back in 2021 on Shiny, so building user interfaces. We gave a talk on living HTA, and that's kind of an extended version of what I'm going to talk about today, and I'll explain why in a second. We then talked about building packages, and all of these papers are available open source and open access online. And last year I went into a Cert HE, and we're going to use that a little bit today. And then this year we're talking about automating health economic evaluation with R, and a new package that we've made open source on GitHub called Bibby. And so a few years ago during the pandemic, I went to go and work in government at the Joint Biosecurity Centre on the response to COVID-19. And one of the problems that we had was data was coming in so quickly, day by day, with test and trace data. And so we needed to do analytics on that rapidly and turn around that very fast. So the process kind of became that each day this huge quantity of data would come in, we would do some modeling work on it, and then we'd create some slides and PowerPoints for politicians to then make decisions and make those difficult decisions you saw on, almost every Thursday evening for a while with the Prime Minister stood in front of the nation. And that was incredibly time consuming. People were staying up till 5 o'clock in the morning to get all that stuff ready. So gradually over time, we began to automate that slide pack. So you ended up with a 500 slide pack that was fully automated from the data from test and trace, all the way through to what the PM saw the morning of Thursday before he made his decision about whether we were closing schools. And that saved obviously tons of time, and it was a really efficient process. And so we want to do something similar in the HTA environment where, okay, so we don't have data coming in every day, but we are having quite a lot of different edits, minor edits to input parameters, to sources, to whatever else that wastes a huge amount of time in copy and paste. So we wrote this paper about how can we use APIs and automated reports to help try and improve that process in a process called living HTA. And this was a mistake on my part, this paper. We did way too much stuff. So we had the living HTA, or the markdown component, how do we automate a report from a set of inputs, but then I also built in all this stuff around sending the model via APIs to remote servers to run somewhere else and keeping that secure, and I just lost most people. It just went over everyone's heads. So we've stripped it back for this presentation and this paper to focus on creating a system to automatically update models, got rid of all the API stuff, just doing it locally. And so the aim is that we want to allow users to be able to change input parameters in the Excel and change the citations, the sources of those parameters, and then rerun a model, get a new set of results, but also generate an automated report. So we're not having to then go through a report and change the citations on every parameter and rewrite text. And so because Gen AI is the big hype thing at the moment, we want to integrate just a little bit of Gen AI. And I'm a lot less optimistic on the Gen AI side than a lot of other people in the industry are at the moment. There's a lot of hype there, but I do think there are small self-contained tasks that can be built into the pipeline using these tools. And so it's useful for us as a community to be talking about where the right places to build in Gen AI are and where and how we ensure we have a human reviewer in that loop. There is a danger when doing this, and we teach a course on this, and I mention this every time. As kind of programmers and statisticians, we often encounter a tedious task, something like copying and pasting a table over. And we think, I want to write a program to do this. And then we spend hours, or days, or weeks writing that program. And then we realize, okay, yeah, this was a massive waste of time. We should have just copied and pasted it. So also understanding where the limits are is important, and I'll talk about that at the end. So we're using a case study for this, and we'll be making the code and the paper open access and the code open source. We're going to use the ISM model for severe asthma and focus on the health economic modeling component of that report. And that was a model that has been translated from Excel to R by myself and Felicity in collaboration with colleagues at University of Colorado. And so we're going to allow for these automatic updates as per previous paper, minus all the API stuff. So here's where it gets much more complicated. So we start with a set of data inputs up in the top left-hand corner, and we're going to read those in to our model using an R package called OpenXLSX. And after listening to Alina's talk, we're going to link up and try and get these two things to work together so that we can have a really nice template, input template, and feed that directly through. We're then going to run our health economic model using a whole series of functions that are tested, and you can look at our paper on packaging models for that if you're interested. That's going to spit out a set of results, and we can create plots and tables and store those somewhere else. But then we're going to feed everything through to RMarkdown. And you might have noticed that the data inputs there now include citations. So what we're going to do is in our input sheet, we're going to include some bib text citations right there. And so our Markdown report is going to contain the results sections, so the tables, the visuals, the plots, everything we need that we spat out from our R model, along with any static images, so model schematic, any other images that need to go in the report that just aren't dependent on the results. And then we're going to return the report from Markdown in Word format, and that's going to be, in this example, the report minus a small section, the summary section of the report, that we're going to then generate with the LLM. So all we're going to use the LLM to do in this example is take the report and write a 2-paragraph summary at the end. Very minor input. And the way it's going to do that is the LLM is going to draft that summary. That summary section is going to get stored in our folder as a R Markdown component, and that's going to get re-rendered back into the report. And then as a final step, our LLM2, the second LLM, is going to go and review the whole report for us, and it's going to spit out a review document that says, this is what I think is wrong with this report. And so it's going to look for things like, are there any internal inconsistencies? Things that might have been said in tables that don't match the text, anything that it flags. And the idea here is that we I personally am more confident using an LLM to try and find my errors, because if it says something clearly crazy and a hallucination, I can just say, okay, I'm going to ignore that suggestion, rather than have the LLM build it and then me have to go through and really triple check everything. And then final step, there's going to be a human review, and that human review is going to review both the report and the LLM's review of the report, cross-reference and say, okay, is there anything else I need to check? So that's the human in the loop component. Okay, so I'm going to do something incredibly risky and try and run this live. And so you can see how this works. Hopefully everyone can see the screen. So what this is going to do when I run it is it's going to grab the inputs that exist in this input template, which is much more basic than the one that Aline went through earlier. It's going to spit out a report, and it's going to spit out a review document of that report. So if I go ahead and run that, and it can fail live, so that I look embarrassed. So it's running a load of tests on the model, and then now it's rendering the initial report. Now it's writing the summary, so it's sending this off to Google Gemini, and then there's the report generated, and now it's doing the LLM's review of that report. And so what we're going to end up with is this report document and a review document. So if I try and open this, oh, it's going to open something else, but that's fine. What we end up with is a report which has your standard kind of report structure. And you'll notice that if I look at one parameter that we're going to change, we have this one parameter here, which is a rate ratio as described in the initial report of 0.361 with this reference here. And so I'm just going to go through an example of just changing that one reference. And so you can see that leads to some tables, some results tables, and incremental cost effectiveness ratios. These are just exactly copied over from the original ISA report, and we've just plugged in the numbers that come out of this specific model run into those spaces, basically. And so in our Markdown, what we end up with is this nice set of references. And as you can see, the last reference here is a paper by Mal. So that's our last one. And you'll see why I said that in a second. And we've got a full table of references, table of parameter inputs at the end. So if I close that and go to our data inputs, so that is just the result of using this single set of input parameters. And so that's the parameter that we're going to change, right there, and this is the source. And so if I now close that, and instead of using that, use this template, which has the exact same set of parameters, except we're changing from 0.39 to 0.6, and we're changing this reference to be Williams et al. That's the only change we're making. So if I just make it that, and then live this, and then rerun everything, we're going to get a whole new report, and that report's now going to contain a new set of results. It's going to update the parameter value in that input table. It's going to update the source, and it's going to add the source to the references. So the whole thing is completely updated. And so this can be really useful if either you expect to have a lot of small changes that are made over time, so people keep changing what their sources and input parameters is going to be, or if you want to run the same model for a large number of countries. So you might think you have like a model for the UK, Netherlands, Spain, etc. Then you can just spit out, you can have 10 different input templates for 10 different countries and spit out 10 different reports. So if I now look at the report 2, you'll now see, hopefully, that it's going to have updated those. So just to go very quickly, you can now see here we've got the Williams et al. Reference and 0.6, and our results are going to have changed. And then at the end in our references, we're going to have this Williams reference here. So it's updating everything as it goes. So going back to slides. And so the tricky thing that we had to implement here is how do you get the inputs and citations to pull through? Because doing inputs in RMarkdown is not new. Doing citations was a new thing for us. And so the way this works is we developed this package called Bibby. Basically what it does is it takes the parameter table, identifies any bibtech that's located in it, and you can export bibtech from like EndNote or any other referencing software you're doing. You can just export the bibtech out. Paste it into the input template. It's then going to update that input table with a RMarkdown tag, and it's going to create a bib file and store the bibtech reference so that RMarkdown can pull those two things together into the format you need. And so this, I mean, to go through a tiny bit of code, essentially looks like this. So we've got this function, update bib file from vector. It just takes the vector of citation inputs and spits out a bib file, and also spits out a vector of RMarkdown referencing. So that's the Bibby side. The GenAI side, we've tried to do an absolute minimal task. So we got it to create the summary, and we also got it to create the review document, which I can show if we've got time in a second. I'm conscious I'm going over. But the idea here is that the GenAI output is being used to generate something that's fully reproducible. So the stuff that we've got, it puts into the RMarkdown, so that if we decide, okay, so we want to change this in some way, but we want to stop using GenAI, we're not tied in to have to ask an LLM to make the update again. It's just changing the code for us. It's changing the code on on that text. So if we want to carry on adapting, we can carry on adapting without using an LLM again. So further edits can be made in this independent process. And I think the review thing is one of those tasks where a lot of people might have otherwise basically uploaded the document to Gemini or ChatGPT anyway, in which case we may as well just build it into the pipeline. If everyone's just going to take it and upload it and ask it questions, we may as well just build that into our modeling pipelines. One final comment is that, for those of you that are interested in what the picture is, I was in a meeting and described using LLMs with Excel as being kind of like a humanoid robot driving a horse and cart. So you have this incredibly sophisticated set of machinery that's being used on quite an antiquated creaking system. And so there's a danger that as an industry we sleepwalk into a situation where we have Excel still being used alongside these LLMs, and people are trying to stitch that together, which is very, very tricky to do. The natural interaction with LLMs is via code, because it's sequential and written, rather than via spreadsheet software. So yeah, I'll leave it there. I've added slides on the GitHub repo. I would say the challenges are the initial setup time. So I think if you expect to update things less than 3 times, probably just stick to doing it manually. The skill set required is really diverse in terms of obviously health economics, Markdown, API calls to LLMs, prompt engineering. It's combining quite a lot of stuff here. And so that combines potentially different skill sets from different individuals, but the opportunities are huge, especially if you start to integrate this process with a user interface. I've just showed that in code, but you could easily just put a Shiny app on the front of that, on that process, and make it much more usable for a non-programmer. So yeah, I'll leave it there and open for questions.
Thanks very much, Rob. Any questions for Rob?
There's actually one online.
Okay.
There's, to start us off, someone's asking about aiming to write their modelling chapter of their PhD thesis using a similar function in RMarkdown. If you have any suggestions or thoughts?
I wrote parts of my PhD in RMarkdown, and I know other people that have. Yeah, I think if you expect lots of things, lots of small changes and tweaks, I think it's really useful not to be having to copy and paste everything over. I think I go back to what I said. I think like as a rough rule of thumb, have like your own rule of like 3 or 5 or something, where you're like, do I expect to change this thing more than 3 times? If I do, probably a good thing to semi-automate it. It depends how proficient you are with Markdown as well. Like if you've used Markdown loads before, there's an initial cost for the first time you use Markdown, just figuring it out. Once you've done it a few times, it won't actually take you that much longer anyway. So then maybe you can bring down that from 5 to 3 over time. So, yeah.
Go for it, Jennifer.
Just again, a quick comment on what you've just said, Rob. I fully agree. Obviously, the first time you learn Quarto, Markdown, these things, it takes a bit longer. Now, everything that I do, even when I have to write a head of department letter or recommendation, it all goes through Quarto because that's just easier and it doesn't take me 3 seconds more. In fact, it saves me a lot of time. So I think if we get over the initial barrier, then there's lots of wins to be had.
And the other thing to recognize is that you may think that you're only going to do this 3 times, but not only are you going to do this exact thing 3 times, but are you going to do something very, very similar in your career more than, say, 5 times, because there's a little bit of translating it? Almost certainly. Like, it's very unlikely, unless you plan on leaving the industry completely and going to do something completely different. You're probably going to reuse this stuff. So, yeah.
Thank you. Great, really nice presentation. And I think this is really wonderful, like you said, that things need to repeat it. And I was wondering, especially with the output of the report for submissions for like larger models where also ERGs have to take like updates or make their own cases, the role of like this visual option that you now have in Markdown, does that cause any issues compared to the coding version, or is there a way of like showing that it is as easy to kind of lower the threshold of making something in Markdown?
Yeah, I think it helps lower the threshold. I think especially for any technical documents that you might want to include code in as well. So if you want, for example, if you had built a model in R that you were submitting, and then you can, in RMarkdown, show the exact steps of subcomponents. You say, this is a really tricky part of the model. I'm going to show like a bit of code and then describe it and then a bit of code. I think that's really, really powerful. Yeah, I mean, you could do that with Word, right? But then you're just copying and pasting like snippets of code, which, yeah, is trickier. Yeah.
Excellent. Okay, one last question over there, and then we will move on.
Thank you very much. How does this process handle confidential data?
As in, like, the
As
concern
in-
with the LLM side? Or,
Yeah.
Yeah. So in this case, we're using, just by default as an open source example, we're using Google Gemini's openly available tool. If you were doing this with confidential data, you'd want to use either an open source model that you're hosting locally. By open source model, I mean an open source AI model that you've hosted locally, so you know that you're not sharing any information. Or if you're working with a pharmaceutical company that has a contract with, say, OpenAI or someone where they've got a like ring-fenced server space essentially, so that that's not shared. That's now really common. Like, this is a problem that a lot of people have faced, and like it's very common now for big companies to have contracts in place around that. So, yeah.
Excellent. Let's thank again Rob for his great presentation.